Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field.
Welcome to the classroom. Today we're going to do a digital image correlation analysis in MATLAB on that landslide that I created in the sand with the Lego geologist doing the observations. Let's have a look at how we can do this in MATLAB. And so we've got to load in our images that we took out of the video file. And so we're going to set the first reference image as the beginning, and then subsequent images, we're going to compare the pixels from one image to the other and track the pixel locations. So we need to set a region of interest. We can draw a region of interest. In this case, we're going to use a polygon, and we're just going to look specifically at the mountain here. Those perform the DIC analysis, so we're going to select the region. We only have one region in this case, and we need to set a seed, which is going to help us to analyze the deformations. Once it's processed, we can look at the displacements. So we can format the displacements so that we can change from pixels to actual deformation in millimeters. So we have to calibrate the analysis. And we can do that by, in this case, the scale of the Lego geologist. We just zoom in here and we set the size of the Lego geologist, approximately 40 millimeters, put a ruler in there so you could get a really exact measurement. So that tells the relationship between the pixels in the image and then the actual displacements. And we can convert then these displacements into strains. And we have to do a correlation analysis in order to calculate those strains. We want to process that, and then we can actually look at the strain analysis results. We can plot those up. We can just cycle through here. So not much happening, a little bit of strain happening. There's a small displacement happening. You'll remember that from the video, and that sort of propagates up. And then we get a larger displacement happening there, and that whole thing has collapsed. It happened fairly quickly in our case. The deformations, you have to do many photos in order to capture it in a very good sequence. Just using 17 pictures was a good approximation to get an idea of that reference image, looking at subsequent images from that, and then comparing the pixels and the deformation that happens. And you can see the area where we have a lot of strain happening is where we have the landslide that's occurred. Now, of course, this is back analysis, but if we didn't know there was a landslide there, we could look at the results and see areas of displacement and then go do further investigation to check them out. That's the engineering link here. We got to look at those deformations and determine what we need to do. Go into the field, collect some more information, make some decisions about whether or not this is an unstable location. We're going to monitor it further. What do we need to do? Do we need to evacuate people, et cetera, et cetera? Those are all decisions that we need to make based on our monitoring data. Thanks for listening, and I hope you enjoyed this introduction to digital image correlation analysis